Imagine walking through a parched desert. The heat is suffocating, and the land is cracked and dry. Not a single drop of water in sight. But then, in the heart of this barren land, a small, unassuming sponge sits quietly, drawing invisible moisture from the air, turning thin air into drinkable water. Sounds like science fiction, right? But it's not. This is science fact. In a remarkable breakthrough, engineers have developed a revolutionary sponge-like material that can literally harvest water from the air, even in the most arid environments. No pipes, no power grid, just a small device and the power of the sun. The idea is both simple and genius. Create a porous, absorbent structure that mimics a sponge, but with chemistry far more advanced. Traditional sponges soak up water from puddles or spills. But this sponge, engineered at the molecular level, pulls water vapor directly from the atmosphere, even when humidity levels drop below 30%. And here's the kicker. The captured water is released when exposed to sunlight. No electricity, no batteries, just solar energy. The device works during the day by absorbing water and then releases it as clean, drinkable liquid when warmed by sunlight. One cycle, repeated every day, sustainably. At the core of this invention is a smart material known as a metal organic framework, or MOF. Think of MOFs as tiny cages built from metal atoms and organic molecules. Their structure gives them a vast internal surface area. 1 gram can have the surface area of a football field. That means more area to trap water molecules, even from dry air. When exposed to sunlight, the MOF heats up and releases the trapped water, which then condenses into liquid form. It's like squeezing out the morning dew, but on demand, and without needing clouds or fog. So, why does this matter? Because over 2.2 billion people on Earth lack access to safe drinking water. Many live in regions where traditional methods, like groundwater extraction or water desalination, are either too expensive or simply unavailable. This sponge-like device could change that narrative, offering a low-cost, decentralized water harvesting solution. Imagine rural communities no longer needing to walk miles to fetch water. Refugee camps, disaster zones, and remote agricultural regions could gain a stable, off-grid water source. The potential impact is massive. But there's more. This isn't just a prototype sitting in a lab. Researchers have already tested it in real-world conditions, and it worked. Even in environments with humidity as low as 15%, that's desert-level dry. What sets this technology apart isn't just its ingenuity, it's its scalability. These materials can be 3D printed or molded into various shapes and sizes. And since they don't rely on electricity, they're ideal for use in off-grid or developing areas. Plus, the device is reusable. The MOFs don't degrade easily. They can last through hundreds, even thousands of cycles. That means a single device could provide water for years with minimal maintenance. The inventors behind this innovation are optimistic, but they're also realistic. They know that for this to become a global solution, it needs to be affordable and manufacturable at scale. They're working with industry partners, aiming to refine the materials, reduce costs, and eventually mass-produce these water harvesters. This is not just a story about material science or clever engineering. It's about hope. It's about changing how we think about resources. Harvesting what was once thought inaccessible. Water from thin air used to be the stuff of legends and myths. Now it's a product of human ingenuity and determination, and in a world increasingly shaped by climate change and water scarcity. This invention is a glimmer of light on the horizon. So next time you feel the dry wind against your face, remember, there's water there. You just need the right sponge to catch it.